thanks for coming back. This is chapter 4.2, standard form of quadratics. Let's go. So what we need to do is, if we have standard form y equals ax squared plus bx plus c, and we need to get from standard form to graphing or finding the vertex or axis of symmetry. Shortcut equation. Equation for the axis of symmetry is x equals negative b over 2a. We need the x value of the vertex. It is negative b over 2a. Okay. So how can you find the corresponding y value of the vertex? Well, if we get the x value, then we can take that and we can plug it back in and solve. So we're going to plug the x value of the vertex into the original equation to find y. So that where we got that x equals negative b over 2a. So therefore the graph ax squared plus bx plus c, where a is not equal to 0, is a parabola, which we've already discussed last section. We know that if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. And we know that the axis of symmetry is now that x-coordinate of the vertex, or in this case, negative b over 2a. So the x-coordinate of the vertex is negative b over 2a. The y-coordinate is this function where we input negative b over 2a, meaning this is just notation, simply stating that once we find the x, we input back into the original equation. Okay. The intercept, or the y-intercept, is 0, c. In other words, we're basically let x equal 0 and then solve for your y. So use the shortcut to write the equation for the axis of symmetry and find the coordinates of the vertex. So we have standard form. So we need to use x equals negative b over 2a, which first you need to know what is a, what is b, and what is c. Well, in this case, a equals 1, b equals negative 4, c equals 1. So using our equation, x equals the opposite of negative 4 divided by 2 times 1, which gives us 2. Okay. Now we take the original function, that g of x. So we take this equation, g of x, which is x squared minus 4x plus 1. Now we're going to take this 2 and we're going to input it into the g of x function. So g of 2 equals 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1 equals negative 4 plus 1, negative 3. So your vertex is our x value, which was 2, comma, negative 3. What's the axis of symmetry? The AOS, x equals, and it was 2, which is what we got there. Hit pause, you try B. Alright, welcome back. So if we notice, we did negative b over 2a, so the opposite of negative 10 is 10. 2 times 5 is 10. 10 divided by 10 is 1. So our x coordinate of the vertex is 1. Now input that 1 that we got from here. We're going to input it into that f of x equation. Did it down here. By doing that, you end up getting negative 1. So our vertex is 1, negative 1. What's the axis of symmetry? It's the x-coordinate of the vertex, which is x equals 1. Remember, an axis of symmetry is a vertical line. Therefore, we always want to put x equals something. So now we need to write each function in vertex form. Okay, so we got a couple bullets, and then we'll do the first one together. Let you try the next two. So y equals x squared minus 8x plus 19. We need to identify a and b. A equals 1, b equals negative 8. Okay, so if we need to find the x-coordinate of the vertex, x equals the opposite of negative 8 over 2 times 1. So 8 over 2, which is 4. Now we're going to substitute your answer into the equation for x and solve for y. We get y equals 4 squared minus 8 times 4 plus 19, which is equal to 16 minus 32 plus 19, which equals 3. So we know y equals 3. So the vertex is 4, comma 3. So now if we substitute the hk, the vertex, into this original vertex form of the equation, you're going to get y equals x minus 4 squared plus 3. The a is the same in standard form and in vertex form. So here's vertex form. Here's standard form. If you notice, the a on the x squared is 1. Therefore, it's the same. So we've just taken our standard form of the equation and wrote it in vertex form. All right. Pretend. 10-point quiz. Number 2, 5 points. Number 3, 5 points. Hit pause. Go. All right, welcome back. Oh, let's check. So by solving for the shortcut method, we get the opposite of negative 2 divided by 2. So x equals 1. Input the 1 to get negative 7 for y. So our vertex is 1, negative 7. If we notice over here, the a term, a equals 1. So if we rewrite our equation, we write y equals 1 times the quantity x minus 1 squared minus 7. Over to number 3. If we take the opposite of 12 divided by 6, we get negative 2. Input that negative 2 back into this original function. So we get, by simplifying, we get y equals negative 7. So our vertex is negative 2, negative 7. Okay, so if we take this 3, we know it's a, so a equals 3. We're going to put it into our vertex form, so y equals 3 times the quantity. The opposite of negative 2 is positive 2, so we have x plus 2 squared. Then bring down that y value and make it minus 7. We now have vertex form. All right, so here's a quest. You're going to do 1 and 2, where you need to identify the vertex, the axis of symmetry, the minimum and the maximum value, or the maximum value, and then do the range of each parabola. You can do the domain also, but we're looking for the range. Hit pause again. Go. Hey, welcome back. Remember, we need a and b, so we need a equals 3 and b equals 18. If we plug into the shortcut, the negative b over 2a, you should get negative 3. So x equals negative 3. Hey, there's your equation for your axis of symmetry. Boom. Okay, to get the vertex, we're going to take that negative 3 and input it back to the original equation. So you should have gotten y equals 5. So our vertex is negative 3, 5. Axis of symmetry is x equals 3. Now we know because a is greater than 1, it's going to open up. So therefore it has a minimum. So it opens up, has a minimum. So everything's going to be greater than that minimum. The minimum value is on the y. The y is 5. So therefore our range is y is greater than or equal to 5. Check in 2. You should have gotten a vertex of 1, 4. Axis of symmetry is x equals 1. Therefore we knew it opened down, so it's a max at 4, which means everything or all the y's that are less than or equal to 4. Remember, both domains, if you did write the domains, both domains are all real numbers. All right, for the last one, let's call it a quest, but together. First one, we need to find the vertex. So, x equals the opposite of negative 3 over 2 times negative 1/2. So 3 over negative 1. So you get negative 3. Input, so we get 9/2 plus 9 plus 3. Common denominator would give you 9/2 plus 18/2 plus 6/2, which y is equal to 15/2. So our vertex is negative 3 and 15/2, or 7.5. Okay, so number 2 says find the y-intercept. Well, we know the y-intercept is at x equals 0. So if we plug in 0 back to our equation, you're going to get y equals 0 plus 0 plus 3. So the y-intercept, or y equals 3, so the y-intercept is 0, 3. So if we go over to the graph, we're going to graph these negative 3. We're going to go up 7.5. We know the graph opens down, so vertex is negative 3, 15/2. We know that it crosses the intercept at 0, 3. So it crosses there. So the notion of symmetry is meaning this. If I said, okay, here's my x, here's my y, I just found 0, 3. I know the vertex is negative 3 and 15/2. So how we can look at this as, these are 3 away. So if I go 3 away from here, you're going to go to negative 6. When we plug in negative 6, you should get negative 6 squared is 36. Negative 36 divided by 2 is negative 18. So right now we have negative 18. If you plug in negative 6 times negative 3, you get positive 18. Negative 18 plus 18 is 0, and what's left is 3. This notion of symmetry, they're the same. So I could go over to negative 6 and up 3. You have 3 points. Now a little bit easier to graph. Draw that down and draw that down. Now again, 5 is going to be better. I'll give you an extra 2 points, but that is okay. Congratulations. Always remember, do your best, forget the rest. Bye-bye for now. Bye-bye for now.
You know